Hello guys, so in this video I would like to discuss about covalent bond, which is another type of chemical bond. So previously we've discussed about the atomic structure and that in IGCSE that the first 20 elements will be important for you. So it is expected that you know your way from hydrogen to calcium at least, and the atomic number is 1 to 20. It represents the amount of proton and electron. Actually, the amount of electron is essential for us to determine the types of bonding that atoms will have, especially the grouping or the electron valence, because the outer shell, the number of electrons, are actually essential for us to determine the types of bond. So in ionic bonding that we have learned previously, in ionic bonds, typically one would give away the electron and one would receive. So it's based on give and take of electron. Okay, for example, like sodium, the atomic number is 11, so we arrange as 281, and it has 1 as the electron valence. So it means that it tends to release 1 electron or creating sodium plus 1 ion. While for chlorine, for example, 287, so Cl will have tendency to take in 1 electron, creating 1 Cl minus ion. So in a way, sodium will form a positive ion, while Cl will form a negative ion, Cl7, right? So it will receive 1 extra electron. So this is the way that ionic bond works. So one would give away the electron, one would receive electron. But what if both wants to receive? So no one would like to give away, because in this case that the one that sodium release, so now sodium does not have any participation in that. That electron now completely moves to this part. But for example, like we have two components that would like to receive here. And if we see that from the ionic bond, typically the one who likes to give are the metals. The metals, so they are around this. So group 1 and 2. And also aluminum. So they typically like to give electron, forming ion, of course. So here they form +1, +2, and also here +3. And here in the middle later we will study. These are transition metals. So now in covalent bond we would like to study mostly between these. So 4 to 7 typically. So they are non-metals usually. Yeah. And they usually would like to take some electrons in order to become stable. They like to take, but they don't give. And for group 4, because they're 4 can achieve perfect number of shell 8 by either taking in 4 electrons or releasing 4 electrons, right? So here they can do both, but in this case it's preferable that they take in 4 electrons. So now how can we draw a dot and cross diagram to represent a covalent bond of some atoms? Usually the question will give something like, please draw a dot and cross diagram for carbon dioxide, for example. How can we draw this? So first we need to determine the group or the electron valence, because the electron valence would be equal to the group. So here carbon, we know that carbon, the atomic number is 6. So if you don't have any access to periodic table, you know that 6 would be 2, 4. It means that the electron valence would be 4. Or it's located in group 4. While for oxygen, 8 would be 2, 6. So it means that it's in group 6, or the electron valence would be 6. It means that the outer shell of oxygen would have 6 electrons like this. While for carbon, it will be something like this. Now in order to achieve the perfect number of shell, I mean like the full occupancy of electron shell, it should be 8, right? For carbon, now it has 4. So now we can write that carbon needs 4 more electron, while oxygen needs 2 more. So in this case, because carbon needs 4 and oxygen needs 2, we have to select what is called the central atom. So one of these atoms will be located in the middle, because now we have 3 atoms, right? So one, of course, will stay in the middle. So now carbon will be in the middle. So the one that needs most will be in the middle. And on the left and on the right will be the oxygen. So now we represent the electrons, the electron valence, by dot or cross. Now let's draw the electron valence of oxygen first. For oxygen, it needs 2. So here we assign 2 electrons here. The goal for covalent bond is actually to give to carbon and to use together, so that they would be able to fill their electron shells together. So everyone will be full of electron on their outer shell. Everyone will be 8. So that's the goal. So because oxygen we already draw 2 here, it needs 2, right? So it really wants carbon to give away 2 to him. But of course, carbon cannot just give it away like that. Just like that, no. So carbon also needs 4 more. So it desperately needs something. It cannot just give away something, right? So when oxygen says to carbon that it requires 4 more, the oxygen requires 2 more, then the carbon say, okay, I can lend you 2, but please also lend your 2 to me. So of course, oxygen put away 2, and carbon will match with equal number of electrons. And then now we can draw the remaining electrons of oxygen. Oxygen has 6. So now we draw 4 more. So we do the same thing for the oxygen on the right side. That this oxygen would like to, it needs 2 more. So it tries to lend from carbon. It tries to borrow from carbon. So it has to offer something as well. Just like when we go to bank, when we want to borrow money, of course we need to put something of equal value to the bank, so that the bank knows that we can pay off the loan, right? So now oxygen requires 2. So it puts up 2 so that it can receive 2 from the carbon. Then we draw the remaining electron from oxygen. So now let's evaluate. The number of dots and crosses should be equal to the electron valence of the atom. For example, the oxygen electron valence is 6. So we see that here, every oxygen has 6 dots. While for carbon, electron valence is 4. So the number of crosses are 4. So now we evaluate case per atom. So the ownership of electron for this oxygen, it consists of this area. So it means that this oxygen, technically, it has 6 electrons, and it has alone with carbon. It shares 2 electrons. So because the oxygen and carbon use this together, they can claim ownership of both of these. The same thing happens to this oxygen. So now if you count in the area of oxygen, all of the electrons in that region for both oxygens would be 8. It means that oxygens are satisfied with this condition. For carbon itself, of course, it also has its own area. It's this part. So if you see, carbon originally has 4 electrons only, the crosses. But because oxygen also lends some from carbon, it also can use their electrons. In this case, carbon has 4 of its own electrons and can share another 2 pairs of electrons with these oxygens. So in the middle, carbon would have in total 8 electrons as well. So everyone will have 8 electrons in this case. Let's do another example. Maybe something like oxygen. Typically, we write oxygen as O2. And we know that oxygen actually is in group 6. So it has 6 electron valence. Since the arrangement is just O2, so we draw 2 oxygens here. How many electrons do oxygen need so that it will become full? it needs 2 more, right? So because one oxygen needs 2 more, yeah, it puts up here. It requires 2, so it has to offer something of equal value. It needs 2, yeah, it has to dare to offer 2 as well, to be shared. So win-win solution. So this oxygen has 6 electrons. So of course this oxygen on the right would have to match with 2 electrons. So now in total they both have 6 electrons each, but they share the middle ones. So this is the region of the left oxygen, and this is the region of the right oxygen. So everyone will be 8 and everyone will be happy. What about hydrogen? So hydrogen is actually a very special case in this case. Why hydrogen is a special case? Because for hydrogen, the electron valence is just 1. It means that while the other atoms here, it needs to fulfill the number of outer shell so that it would have 8 electrons by the outermost shell. For hydrogen, the outermost shell can be filled with just only 2 electrons. So hydrogen would only require 1 more electron to be full. So unlike other atoms here from group 4 to group 7. So let's give an example. For example, water molecule. So water consists of 1 hydrogen atom, 2 hydrogen atoms. So the first shell is 1. So it needs 1 more. While for oxygen, the valence is actually 6. So it needs 2. It needs 2 more. So the one who needs most, we put at the center. So oxygen, hydrogen, hydrogen. So we start to try to assign electrons. Yeah, we draw the electrons by the ones who need the least. So who needs the least here? The hydrogen needs only 1. So then we put 1 here representing the electron valence of hydrogen itself. So now, of course, because oxygen wants to use this, it has to offer something also for them. Oxygen has 6 electron valence, and I already draw 2 here. So it has 4 more, yeah? 1, 2, 3, 4. So this will be the region of hydrogen. So each hydrogen will have 2 electrons to play with. And they're happy with it. The first shell is full anyway. While for oxygen, in total it will have 8 electrons, 6 electrons which it owns by itself, and 2 other electrons that are shared by the hydrogen. If you encounter more complex example, for example like C2H4. Yeah, something like this, or maybe C2H6 first lang. Yeah, something like this. So this is rather complicated, right? So for carbon, still we find out the electron valence. So 2, 4. Okay, it needs 4 more. While for hydrogen, just 1. It needs only 1. So now let's draw the one who needs more as the center atom. But we have 2 carbons, so maybe they will do this. So you draw the one who needs the most first. Carbon and carbon. So carbon has 4 electrons. And then there are 6 hydrogens. So where can we draw? So 1 carbon has 4 electrons, right? I would say that this would share 1 electron each to make the bond. So now because carbon has 3 more free electrons, it can bond with another hydrogen. Maybe I will have to pick different color here. Something like this. Nah. Yeah. Here also, this carbon has 4 electrons, so we can draw 3 more here. So something like this. Yeah. This one, this one, this one. So now everyone would be happy because every hydrogen would have 2 electrons and every carbon would have 8 electrons. It's looking kinda complicated, but I hope that you would get the idea. All of them need to be bonded, so you cannot leave just one out. So we draw from the one who needs most first, and then draw the surrounding. So sometimes we have to use logic in this case. Do we put 1 or 2 electrons? Okay? So just like ionic bond that we have giant ionic bond, for covalent we also have giant covalent bond. For example, like this type of carbon structure. Carbon is a very peculiar atom because it can form like chains. Yeah. So graphite or carbon, it's actually composed of carbon atoms that are shaped like this. Yeah. So they form chains. For example, like this, just like beehives. Yeah. Now, however, it's not only 2-dimensional because it can also stack up in a 3-dimensional way. Something like this. So even 3 stacks maybe. Something like this. And all of them are connected to each other, making the bonds to be extremely strong. So giant covalent bond are a large network of covalent molecules that form this type of structure. So typically graphite would be something like this, and also silicon compounds, so silicon dioxide. So it has a property of very high melting points, very difficult to break the bonds, and also typically they are solid. So it's kind of difficult for them to conduct electricity, with the exception of graphite. Diamond would not conduct electricity. Okay? So I hope that you can draw dot and cross diagram. At least these are the more important parts. And you know the difference between covalent bonds and ionic bonds. The main takeaway, the definition of covalent bonds are chemical bonds that are formed by sharing of 1 or more electrons. So by definition of sharing means that using together.